So welcome back everybody. Today is a wet, dreary, nasty day outside and you can probably hear the rain on the tin roof of the shop. I hope it doesn't mess with my audio too bad. I think it'll be all right. But I wanted to show y'all my blade sharpening operation today. I get questions on the channel every now and then about how I deal with my blade sharpening for the sawmill. Do I send them back to Wood-Mizer? Do I do it myself? How do I deal with that? Well, I'm going to let y'all see exactly what I do. I've got my sharpener set up right over here. The setter is set up right over here, and we are going to sharpen and set some blades, and I will go through the very nitty-gritty details about how I manage this or how these machines work, and I certainly hope that it is interesting for you. So let's go ahead and complete the setup on the sharpener and we'll get started. As you can imagine, this right here is the shield, I guess you could say, that all of the metal filings from the blades, when the rock here runs through a blade, this is where the metal filings hit, and of course, as you can see, they all get caked up pretty badly. And I want to remove this before we get started, or just at least most of it. I don't know how difficult it'll be. Not too bad, it looks like. There we go. We just want to clean that up so we get a much better vacuum. So I'm going to put a vacuum nozzle right in here to cut down on the dust. All right. So this is the back and underside of that shield that we were just looking at, and I don't really think this is designed to accept a nozzle like this. That's why I put this little zip tie right here just to hold that nozzle in. But let me tell you, this drastically decreases the dust that's floating around in the shop. And of course, you don't want all that dust in here in an enclosed area, and this right here is really the solution to that. So let's go ahead and get a blade on this, and then I will get up real close and kind of show you all the major components of this thing and the nitty-gritty. You're really supposed to flip this up so that you can get this blade up in here, but with the vacuum cleaner nozzle in there, it doesn't work that well doing that, so I just kind of leave it down. All right, let's get y'all up close so you can see what's going on. All right, so let's go ahead and get a closer look at this machine. This is the Cook's Cat Claw sawmill blade sharpener. It's made by Cook's Saw Manufacturing in Dothan, Alabama, and it's a very heavy duty, well-built machine that gets blades cat claw sticky sharp. This is not a sponsorship or anything. I did pay for this with my own money, but I just wanted to let y'all know in case y'all are in the market for a sharpener. Cook's is a good company to do business with, and this is a really well-built machine. So here's the main components of this. You've got your grind rock motor right here. That motor is connected by a belt to the grind rock right here. You've got, I probably will butcher most of these proper names, but you've got the clamp right here, and this clamp system clamps your blade. It's actually got a spring tension adjustment right here that you can adjust in or out according to how tight you need this to be clamped into the machine. The blade is fed through the process by this switch and rheostat right here, which controls that motor right up there, which runs this arm, and this arm basically just pushes the blade through the process. What'll happen is this dry rock right here, and this is just a standard rock that you have to shape once you get it. It's like a square rock that you would see on a table grinder, like maybe a real small table grinder, or maybe even a side grinder. You would take that rock and you would shape it with this rock right here. And once you get it shaped, you're ready to turn it on and let it go. What this rock will do is it'll brush against the back of the tooth, down onto the front of the tooth, and then ideally it'll brush down into the gullet and remove a little bit of material into the gullet as well, although that's not totally necessary. I do like for it to do that just to take a little material off, and that's just kind of the way I like to do it. So let's dress this rock really fast, and then we'll go ahead and turn it on and let it go through the process, and I'll show you how it works. I mentioned that we wanted to dress this grind rock here before we get started. What happens to this rock is that it grinds and grinds and grinds, and metal filings will get built up in the little cracks, the little grooves, not grooves, but the little pits that are naturally in this rock, and that'll decrease its ability to sharpen properly. So what we want to do is we want to take this dressing stone here and just kind of very lightly bump it against this while it's going, and that'll remove some material and get you a fresh face on the rock. That's all I'm going to do. It doesn't take very much, and yes, it would be much easier to flip this whole thing up, but I have the vacuum tube on it and it really doesn't allow it to go back as far as you want it to. So I'm ready to turn it on. Before I turn it on, I want to adjust this right here up. That adjusts the depth of the grind on your grind rock right here. I want to adjust that up, and I want to adjust this also. So, and I always get this wrong the first time, but that is correct. I want to adjust this right here so that it pushes the blade farther than the rock will grind. And I want to do that because I want it to be starting at a spot where it's not grinding, so I can adjust all this stuff while it's going, so I can get just the right amount of grind on every blade. And every blade is going to be different, so you have to do that every time. So we'll go ahead and get our vacuum cleaner going and get it started. So it's usually sufficient just to let these blades run through one time, unless it's just, you know, extraordinarily dull or unusually dull. I let this one run through twice because I had a little bit of trouble with the adjustment there right at the beginning, and I wanted to make sure all of the teeth were as even as possible. So what we'll do now is we'll just take this one off and stick another one on, and then after we do that one, I will show y'all how I set the teeth as well. Now you don't want to take a whole lot of material off on every single cut, because the more material that you're taking off in one pass, the more damage, the more wear and tear you're doing to the blade, as well as the grind rock itself. And what I'll do with this blade is, oh, by the way, it's a really good idea to use some goggles when you're unrolling these blades, because these things slap you right in your face. You may have some issues. Of course, I tell you what, stuff like this, to try to do it on camera, it never works out. There we go. So I'll get up close here and I'll give you all some before and after shots of these teeth before they get sharpened and after they get sharpened, just to give you all an idea of exactly how much this machine does and how bad these blades can be sometimes. Oh, these aren't too terrible bad. This one's definitely dull, but it's not unusually dull. Let's get a little bit closer here. All right, guys, so this is the Cook's setter. It is a blade tooth setter. It does 2 teeth at a time, so that makes it, of course, twice as fast as one that might do 1 tooth at a time. It's actually a pretty fast machine, and I have not done this in a really long time, actually. So I did a practice blade before I stuck this one in just to make sure I wouldn't make a complete fool out of myself on camera. But to really have an understanding of how this thing works or what it does or why it does what it does, I'm going to give you all a real good close-up here of these teeth, and I will show you all what the set on a tooth really is before we get started. All right, guys, so here's my practice blade that I used, and just keep your eyes on this blade right here. Ignore this bunch over here. So if you look at these teeth right here, you can see that that tooth is straight up and down. It doesn't deviate to the left or the right. That tooth deviates off to the left. That tooth deviates off to the right. And again, that one is straight. And then the process or the pattern starts all over. You've got left, right, straight, left, right, straight, and so on and so forth. Now, these teeth have to be in this pattern, and they have to be set at a very specific deviation off of the main blade, because if they're not, it's just not going to cut wood. If they are all straight, it would wander around in the cut on the log. If they're not set properly, you're going to have all kinds of saw marks. It's not going to clear out sawdust like it should, and it just won't work. This is an incredibly important part of the sharpening process. So let's check out the setter next. There's a couple of levers that I just was not able to get into this shot, but y'all will see how those levers work very shortly here. So this is the main components, I guess you could say, of the tooth setter. You've got your blade, of course, that runs through this channel right here, and there are a couple of dies, and those dies are the things that do the work. Those are the things that push the blade teeth in one direction or the other to make sure those teeth rather get set properly. Basically, all it does is it bends. It bends those teeth into submission, I guess you could say. And I'll try to get a closer up shot here in just a second, but I just wanted to show you all from here. And it still needs to be adjusted for this blade, but I just want to give you all an example. So the blade runs through these dies, and when it comes out, these gauges kind of check your work. You can see these gauges are moving, and the work gets checked on those gauges. Pretty simple, not a whole lot to it, but it's incredibly important. You don't necessarily have to set a blade every single time you sharpen it, but you do have to set them sometimes. So the set on these teeth should be around the low 20s, and these gauges here measure in thousandths of an inch, so the blade set should be somewhere between 20 and 25 thousandths of an inch. I usually set mine between 20 and 28. If it starts getting a little bit higher, I'll reset the dies so that it, does it properly. I think I checked a Wood-Mizer blade one time, and it was something, a brand new one, and it was something along the lines of 22 1/1000ths of an inch. I think I read somewhere people were doing it right at 24 1/1000ths of an inch. I don't know, if I can get it between 20 and 28 thousandths of an inch, I'm fine with it. Let's go ahead and get this set up properly, and we'll run through this blade. So first off, you want to make sure your blade is at the proper level. What I mean by that is this blade has to be high enough or low enough so that these dies hit the tooth rather, at the proper spot so that it bends correctly. So what we'll do, this one's a little bit low, so we'll just adjust that blade up a little bit. And that should be good just like that. The next thing you want to do is zero out your blade. So what you're going to do there is find a straight tooth, put it on this dial right here, engage your dies, and then set the dial rather, back down to the 0 mark. Then what you'll do is you'll advance the blade through a little bit and do the same thing with the opposite dial. And basically just what you're trying to do there, all blades are a little bit different, so you have to do the same thing with every blade. You're just trying to make sure your gauges are going to be accurate, or dials rather, are going to be accurate with every single blade. And I'm going to double check my work here, and looks like we're pretty close, so that's good. Now we're almost ready, actually we are ready to start setting here. We'll get the blade in the proper position, engage, and then check our work. And I don't think our work is very good. In fact, that is way off. I'm not sure why it's so far off. Let me fiddle with it a little bit and I will be back with y'all. So for some reason I did not turn the camera on when I wanted to, so y'all missed a little bit. So I got my issue straightened out, and also I checked how far these teeth were being set to, and I found that this die over here was not setting the teeth as far as it should have been setting it. This dial over this depth gauge checks the work of this die right here. It wasn't quite deep enough, so I loosened up my set screw here, readjusted my die, and now it's doing a really good job. It's setting them at, this is about 23 1/1000ths on this one, about 27 on that one, 25 on that one, 23 on that one, and yeah, that's looking really good. Looking at 24, 23 on that one as well, and this one is doing a really good job. Right in the 22 to 25 1/1000ths range on most of these. That one's about 22, so yeah, that's looking great. I'll give you all a little bit of a closer look and we'll finish out this blade. You may have noticed on that close-up shot that this die was registering almost 30, somewhere between 28 and 30. And it is still kind of doing that. That's a 27 1/1000ths. That's 27 1/1000ths. 27 1/1000ths. Sometimes it just kind of drifts, and I don't think it's an adjustment issue with the machine. It's got to be, it must be an issue with the blades. I don't think there's really a deviation in the softness of the metal between teeth, but it may be the case that those teeth have already been done and it's just pushing it a little bit more. I really am not completely sure. if you're OCD, and I think I've got a little bit of that myself, it will drive you completely crazy. Really what you've got to do is make sure you're kind of within a general area. I think the low 20s is probably best, 20 1/1000ths to 25 1/1000ths of an inch. But if you get up to 30, it's really not going to be the end of the world. So we're finished with this blade, and I can see it starting to overset some of these blades because I'm back at the starting point. What I'm going to do now is just take this blade off, and I'm going to set a time lapse for an hour. And what I'm going to do is just set blades, sharpen blades, have the sharpener going while I set blades, and see how many I can get done in an hour's time. So let's go ahead and do that, and we'll see what comes out. So guys, that's going to have to do it for this one. I stopped at the 34-minute mark, 34 minutes and 44 seconds, and I'm having some adjustment issues with my setter, so I'm just going to have to stop right there. But I went through, I completed 2. It doesn't look like 2, it probably looks like 3, but that is actually 2 bands right there. Those are complete, and I was in the middle of this band right here, and I'm having some problems with the band going down into this little bearing right here. It's probably have to go back to the manual and really see what I'm doing wrong here. But anyway, 3 for a 30-minute period. I think if you really know what you're doing, I am not a professional by any stretch of the imagination on this, so I really think if you got some good practice with it and your machines were in good working order, that you'd probably be able to do 6 or 7 of these an hour. And I mean, really, if you want to charge money for this and try to do it for other people, which I do sometimes, just kind of local folks, if you charge $7 for a blade and you're able to do 6 an hour, you're looking at $42 an hour. If you charge $8 an hour, I mean, that's, what is that, $48 an hour? It's not smart to do math on camera, I promise. Yeah, $48 an hour. So I think feasibly you could probably make $40 or $50 an hour if you decided to get into something like this, and probably pay for itself pretty fast. But anyhow, that's going to do it for this video. I really appreciate y'all watching. Sorry it didn't end quite like I wanted it to end, but sometimes that just happens. But I'll see y'all on the next one. Hope y'all enjoyed it, and yeah, see y'all then.